All right, so let's go ahead and start talking about this. First, the paper that you have in front of you that looks like this chart. This is a chart of all the formulas that we're going to be using for like the next 2 weeks. You'll probably have your test for this section that we started last week on most likely Thursday of next week, not this week, but next week. And you probably have at least 8 days to go through everything and review it. So I'm thinking Thursday will probably be good for our test. But if I need an extra day, then I might push it to Friday. Anyway, on this chart, it has lots of information on it. I made this a couple of years ago, and I'll let you guys use this for this entire section. I'll even let you use it on a test. However, when it comes time for the FSA, are you going to have this as a reference sheet? No. The FSA, there is a reference sheet. However, there are very limited formulas that they give you when doing this. So on here, there's a lot of formulas. Pretty much what they give you is things like volume equals base times height. And volume equals 1/3 base times height. They don't tell you what shape it's for or anything like that. They just give you that very general, generic formula. So most of these ideas you do need to know because they don't tell you what to plug in for any of it. Now, in almost every single one of these formulas, you'll see this capital B, right? Capital B stands for area of the base. So we had formulas from before spring break for 2-dimensional figures. We're still using those. Anytime you see big B in any one of these formulas, you're using a formula from that previous worksheet where we're doing area of a figure, or a 2-dimensional figure. On the first one, we have a triangle as our base in this prism. So since we're using a triangle, that means that the formula we would use for area of the base would be the triangle formula. So you have 1/2 base times height. Now, once you have that, you can find the area of the base, and then you can plug into the other formulas. Now, for the surface area formulas, I also listed numerous ones. The reason why I did this is because you can use a basic formula a lot of times, like 2 times B plus LA, which is 2 times base area, plus lateral area, and that gives you the entire surface area of the whole figure. Or you can break it down, and for each one of those parts, you can plug in their individual equations and just do it as one whole formula. All right. So you can do it in parts, or you can do it as one long formula. Either way, you should get the same answer. Now, the 3 that we're going to look at today, we're going to look at prisms and cylinders. All right. We're only going to do the surface area part. So on that other worksheet I gave you, we're only going to look at the front side today, which is the side that says 12-2. All right. So go to that other worksheet, the one that says 12-2. Back up to the top. So it looks like this. Now, yes, there are formulas on here as well, and you'll notice that maybe they're the same, maybe they're slightly different. On here, the one that I had listed on the other page for surface area was this right here. Surface area equals perimeter times height plus 2 times B. Now, for height, on this one, they use that lowercase h. On the formula sheet, I listed an uppercase h. The idea behind that uppercase h is it stands for the height of the entire solid. So a lot of times you'll see them use that uppercase h so that uppercase h, so we're talking about the height of the entire solid. Now, the height of the solid for a prism is going to be the distance between the 2 bases. So over here on this diagram, they have a couple different things labeled. Now, we do need to know that our bases are the ones that are parallel and congruent. Our lateral faces are going to be all these other faces. So the ones that aren't the bases, the ones that are on the side, the ones that are rectangles on a prism, those are our lateral faces. So when they say lateral area, we're talking about all that surface area that's part of those rectangles. All right. When we say surface area, we're including both the lateral area and the base area, so it's all the bases together. Whenever this up. Whenever we're doing a shape though, our formula is going to change based on whatever the base is. So on this one, this example uses a pentagon as our base. Well, when we have that pentagon, right, we're going to have to use a couple different formulas. You might have to do 1/2 AP or 1/2 ASN. And when you have a regular polygon, you might even have to go back and use sine, cosine, or tangent. So a lot of those things still keep coming back. Right. In this formula, though, we also have perimeter. That capital P is perimeter of our base. Well, where's this formula actually coming from? If we look at our shape is made up of a couple different pieces. We have 2 bases, which are both pentagons. There's 2 of those. When we do the surface area in our formula, it calls for 2 times capital B. We have the base area times 2. The other part, the P times H, that is a formula for lateral area. When we open up the entire net, what shape is the rest of this? Rectangle. How do you find area of a rectangle? Base times height. So now, on here, the base of this rectangle is actually the same as the perimeter of the base, because this big rectangle, when we unfold it, it's wrapping around that other shape that is our base. So what was our perimeter of the base is the same length as this top edge of this rectangle. So when we say perimeter times height, we're doing base times height of this whole rectangle by doing the perimeter, which is the entire length of that top edge. Now, there are different ways that you can do this. So you can break it down. These are formulas that work. They should make the work faster so that you can get through the problem quicker. But could we find the area of each of these individual pieces? Yeah. All right. So if you forget some of these formulas, but you know a lot of the 2-dimensional area formulas, you can still find surface area. You can still find lateral area. Because we can find the area of this rectangle. And if we know this rectangle, we actually know these other 5. So I can take that one, times by 5, I have my lateral area. So there are other ways to do this. All right. These formulas are just one of the methods that works, and they'll work every time, no matter what shape you're dealing with. All right, let's go up to the first example here. All right, on example 1, we have what shape first? What shape for number 1? And a triangle. All right. So we have a triangle. That triangle acting as our base. So this is a triangular prism. All right. Again, know this because we have these 2 triangles are both parallel and congruent on the figure. That's why that one's considered our base. Now we can find all the missing pieces or all the parts that we need in order to find both lateral area and surface area, because that's what they're asking for. Before we can do either of those 2 formulas, we need to know the area of the base. So on this one, since you said that my base was a triangle, what's my formula for finding area of a triangle? Half. Yeah, we need the half in it. So 1/2 base times height. Well, 1/2, we have a base, that's 4. We have a height of the triangle, that's 3. So 1/2 of 4 is 2, 2 times 3 is 6. That's the area of our base. The first thing we need. Now, the next thing that we need is our lateral area. Lateral area is going to be the perimeter of the base times the height. Well, what is the perimeter of the base here? I have 3 for this side, 4 for this side. Do I know what this length is? No. But can I find it? Yeah. How do I know what that side is? All right, so it is the hypotenuse of the right triangle. How could I find it? One method to find it, or tell me the answer. Huh? If you use Pythagorean theorem, that works. There's a faster way. You can recognize this as 3, 4, 5, one of our triples, right? Again, this is our 3, 4, 5. I've said many times, we are going to see those triples come up many, many, many times, right? And the 2 that you'll see the most often are 3, 4, 5, and multiples of that, as well as the 5, 12, 13, and multiples of those. Those will come up the most often. There are others, but those are the 2 I stress the most. So 3, 4, 5. We have 3, we have 4, we have 5. Again, could we use Pythagorean theorem? Yes, that would have worked. It would have taken us a little extra steps there, but it does work. 3, 4, 5. If we add all those up, what is the perimeter? Three, 4, and 5, add up to 12, right? The height. Now, this is the height of the solid. So here's one base, here's the other base. We're looking at the distance between them. Which one of those is the height of the solid? Most common mistake would be to say 3. It's 10. Again, we're looking for the distance between the 2 bases. That's going to be our height of the solid. So 10 is going to be the height of the solid. So for our lateral area, we have the perimeter of the base, which is 12, times the height of the solid, which is 10, for a total of 120. Now, we've answered one of the questions. The other question, surface area. Well, surface area was our lateral area. And it doesn't matter which order you put it in, so I don't remember which order I have it in on your chart. But we're adding the lateral area and 2 times the base area. Right. You could also do it the other way, that's fine. But we found lateral area, we have the base area. So we just have to plug in those other 2 numbers. Lateral area was 120. Base area was 6. So we have 2 times 6, 12, added to 120. That's 132. Now, before I can say we're done with this, we should always include units. We're still talking about area, so just like in the last section, our unit should be squared. So all 3 of these values, whether we're doing area of the base, we had meters for all these single dimensional measurements. So the base will be in meters squared, so 6 meters squared. The lateral area, which was 120, will be 120 meters squared. And then the surface area will also be 132 meters squared. Yeah, always include your units as part of your final answer. Any questions on that first one? Now, where it's going to change on each one of these is right here. That first line, where we're doing our base formula, that's what's going to change as you go through this. The rest of it's the same for these prisms. So on number 2, what's our base? What shape? All right. Well, it's not quite a square. It's close to being a square, but it's a rectangle. Now, you have to decide which base you're going to call base on that one, but you're going to use area of a rectangle. So you have base times height. On number 3, what's our base? The pentagon. So when we do our formula for area of the base, we'll do 1/2 AP or 1/2 ASN. On number 4, what's our base? What's our base on number 4? Trapezoid. So when we do the base area, we're going to do the 1/2 B1 plus B2 times H. So again, each time you do these, your base is the part that's changing. All right, that's what you, all the other stuff, finding ladder area, finding surface area, that part stays the same. Each of these problems. All right, let's go on to the other one. I want to take a look at a cylinder, because prisms and cylinders are actually very similar when it comes to formulas. There's a lot of relationships there. The major difference is not really the base part, because for our prism, our base is constantly changing to these different shapes. So on this one, when we have a cylinder, our base is just changing to a circle instead of another polygon. But the actual formulas are very close, because when we talk about our lateral area of this shape, we did perimeter times height. When we go over to a cylinder, well, a cylinder doesn't have a perimeter because our base is a circle. But when we talk about a circle, we still can find the distance around it, right? What's that called? Circumference. So on here, look at our formula. On the last one, our formula was lateral area equals perimeter times height. On this one, we don't have perimeter, we have circumference. So we're doing circumference times height. On this worksheet, they wrote it out as 2 pi r times height. Well, what is circumference? 2 pi r. That's what they're doing here. Because whenever we have our cylinder, just like on the other one, when we unfold it, we get a rectangle. Well, the top edge of that rectangle is the distance around that circle, right? So whatever that circumference is, that's the same as the length of this top edge. So we're doing circumference times height, because circumference is acting as our base of the rectangle times the height of the solid is the height of that rectangle. So it's kind of the same idea, even though it's a different shape. Other than that, our surface area formula, you know, it's pretty much exactly the same thing. Ladder area plus 2 times the base area. Same formula, just if we went further with it and plug values in, then we're plugging in formulas for a circle each time. But it's the same concept. So let's do an example. On that first one, they give us 2 measurements, and that's enough. This is our what for that circle? It's our radius, yeah. And the 12 represents what? It's 12 represents the height. This is the height of the solid. So we're going to go through the same steps. Base area. Well, for a circle, we're doing pi r squared. Yeah, this is where all those other formulas come in, right? When we're looking for a base, we have to use one of those formulas from that week before spring break. So pi r squared. Now that we have that formula, we're plugging into it. The radius is 4. 4 squared is. Now, I know up here it says we're going to round to the nearest 10. I'm going to leave it as an exact value for right now. All right, so 16 pi. I'm going to stop there. Go on to the next part. We need our lateral area. Our lateral area is found by doing the circumference times the height. Or again, you can switch out circumference for 2 pi r. So if we're plugging in, we already have the radius is 4. And the height We already have is 12. 2 times 4 is 8. So we get 8 pi. So 8 pi is our circumference of that base. 8 times 12. That's going to give us 96 pi. So that's our total lateral area for this shape. And then we need surface area. All right, well, surface area, same as before, is going to be the lateral area plus 2 times the base area. We now know that the lateral area is 96 pi. We know that the base area was 16 pi. So I have 2 times 16, that gives me 32. They both are in terms of pi, so I can just add them together. The 32 plus 96 gives me a total of 128 pi. Now, all my answers are currently in exact value or in terms of pi. It's easy to stay this way until the end. And then if you need to change it to a decimal, then multiply by 3.14. So if I wanted to change each one of these, I could go back now and multiply each one of those by 3.14 and get my answer as a decimal. But there's no point in dealing with decimals on any of this until we get to the very end. Because if I had decimals all the way throughout this to the very end, there's a chance I'm going to make a mistake with either typing it into my calculator or rounding it wrong. And then I'll have the wrong answer at the end of the problem. So I highly recommend leaving it as exact values until the end. And then for the final answer, you need to change it to a decimal, then change it to decimals. But I'm going to go ahead and leave it like this for right now. These were in centimeters, so all these values are in centimeters squared. And it's okay to have exact values for pi and then write centimeters squared after it, or whatever the unit is squared. Any questions on these? Now, this one is going to be pretty much the same thing every single time. Unlike the other set where we're switching out the base each time, for every single cylinder problem, it's the same. The only thing that they could change out is instead of giving us a radius, they might give us a diameter. So the first thing that we're going to have to do is cut it in half. Other than that, there's no difference on any one of these problems. So number 1, number 2, number 3, number 6, do the exact same steps. 4 and 5, they give you a diameter. So you have to cut the diameter in half, and then it's the exact same steps. We're not changing the base. The base is always a circle for a cylinder. Any questions? All right. Again, those remaining 5 on each part, that's your assignment. I want you to try those. We'll go over the correct answers tomorrow, and then we'll move on to the area that's on the area, the volume that's on the back tomorrow. So we're not doing volume today. We'll do that part tomorrow. All right. So just page, well, there's 2 of them there. So 12 and 13. 12 and 13. Total of 10 problems. Like I said, for 13, it's kind of repetitive. For 12, you just have to switch out what the bases are. Yes. Yes. Hold on 1 second.